Hi everyone, welcome to part 2A of our Module 6 lecture series. This short video will go over how you can set up an independent t-test in SPSS, as well as how you would interpret the results that come into the output. So with that being said, let's get started. I have a example research scenario where the purpose of, or the research question, if you will, purpose of the research, was to investigate whether an exercise or weight loss intervention was more effective in changing cholesterol levels. So all we're interested in seeing is there a difference between an exercise program versus a weight loss program, with our outcome being cholesterol levels. These were the methods that were defined in my example packet. So we have a random sample of inactive males. They were classified as overweight, and they were randomly split into two groups. So that automatically tells us that's our independent variable, as we are categorizing people, and we have two groups, or they're split into two groups, so those are independent samples or between subject variable. So our intervention, or our independent variable, if you wanted to identify it, is the type of weight loss program that a person would be going through. They had one group go through a calorie-controlled diet, so we can say that's our diet program, and then the other group went through an exercise training program, so that would be the exercise portion. The dependent variable is the mean cholesterol concentrations, and then again we were interested in comparing the two groups at the end of a treatment program. So in SPSS, let's say that we have moved all of our individuals into a spreadsheet. We've got their cholesterol concentrations, we've identified what their treatment group is. You'll recall that in SPSS, when you set up your variable view, if you don't want to have a text that is identifying your treatment group, you can always assign values for your nominal variable. So in this particular test, a value of 1 would represent diet, a value of 2 would represent our exercise group, and we would do that before we actually start this analysis process. But to get to our independent samples t-test analysis window, we go to Analyze, Compare Means, and then Independent Samples t-test. Pretty simple. From there, we identify the variables that we want. So initially, when this window pops up, your variables will be in this box to the left, and then your test variable is going to be the dependent variable. Your grouping variable will be the independent variable, and initially what will show up is two little question marks right here. What you have to do is click on this Define Groups button, and then indicate the value that you've assigned to each group. So as I said before, for this example, a value of 1, or group 1, is representing our diet program, and then our group 2, or variable 2, value is representing our exercise program. From there, you would click Continue. That'll take you back to the t-test dialog window, and then you'll click the OK button to generate your output. So there are steps to reading the output. You'll recall from our previous lecture video that we talked about different assumptions that have to be met. Namely, for this one, we are going to be checking Levine's test to see if we have homogeneity of variance between our independent samples. So that is kind of our first order of business in our output. The output that I had from the example in layered statistics is oriented differently than what you would see in SPSS, and I think the reason is that the output is rather long, or the table can be pretty lengthy. So really, the way that it would be set up in SPSS is similar to the example that I gave you guys in the previous lecture, where the t-test statistics and intervals and everything, they're actually listed to the right of Levine's test. And instead of two columns for if you have equal variances assumed or not assumed, those are actually rows. So The way that I've set this up should help you when you're identifying what values you're targeting, but the way that we read it is essentially the same. So again, Levine's test is going to be helping us figure out if we have homogeneity of variance, and you can see the F statistic is listed here, and then we have our sig value, which is listed here. So that's kind of our primary focus for being able to interpret if we've met our assumption of homogeneity of variance or not. So if you'll recall from the previous lecture video, we said that the null hypothesis for Levine's test is that the variance of each sample is the same. We can identify from this table that our p-value is 0.579, which if we evaluate this in comparison to our alpha, which is 0.05, it is greater than 0.05, which tells us to accept the null hypothesis. And our interpretation of that p-value would then be that there are, in fact, equal variances between diet and exercise groups. So we can reasonably assume that we have met our assumption based on the result of this Levine's test. After we've checked our assumptions, we then can go into interpreting the t-test results. So going back to the same table, you recall I said this usually is what confuses students because you have two p-values listed in the same table and sometimes it's like, which one do I look at? Okay, so we're looking under the area that says t-test for equality of means, and specifically we're interested in the p-value that says it's two-tailed. Okay, now from our Levine's test, we said that we were greater than 0.05, so that indicated that we are going to assume equal variances, so that tells us which column to read. In your guys' outputs, it will tell you which row to read, because again, these are flipped in orientation. But that would end up giving us a p-value of 0.020. Okay, and so when I ask you guys like, oh, what's the what's the probability that exercise and diet interventions, what's the probability that they lead to equal cholesterol concentrations, right? And that question is directly related to the null hypothesis, which I've written out in terms of the variables we have investigated. So when we look at our p-value, 0.020, that is less than 0.05, right, which is our alpha value. So because we have a very small probability of type 1 error, we can reject the null hypothesis and reasonably assume that there is a significant difference between these two groups. So an example of how you might write your interpretation of your p-value is that the exercise program resulted in a significantly different cholesterol concentration than compared to the diet intervention. I abbreviated or shortened that because it did not fit on the slide. But hopefully this video is helpful in guiding you through reading your output, and I'll see you in the next video where we will talk about setting up and reading the output results for a paired samples t-test.